We keep saying clustering is hard to judge because there are no labels. So let's fix that. How do we actually measure whether a clustering is any good? A good clustering has two qualities working together. First, cohesion. The points inside each group should sit close to one another. Second, separation. The groups themselves should be far apart. Tight on the inside, well spaced on the outside. Let's look at each. Cohesion first. Picture the distance from every point to the center of its own cluster. When those distances are small, the group is tight and cohesive, a confident, compact cluster. When they are large, the group is loose and fuzzy. Separation next. Now look at the gap between one cluster and its nearest neighbor. A wide gap means the groups are genuinely different. If two clusters nearly touch, maybe they should have been a single group all along. The silhouette score bundles both ideas into one number, computed for every single point. For a point, we measure A, its average distance to the other members of its own cluster, and B, its average distance to the points in the nearest other cluster. The silhouette is B minus A, divided by whichever is larger. In plain terms, how much better does this point fit its own group than the next best group? That score always lands between -1 and +1. Near +1, the point is snugly inside the right cluster. Near 0, it sits right on the border between two groups. And below 0, it is actually closer to a different cluster, a sign it was probably assigned to the wrong one. Average the silhouette over every point and you get one overall score for the whole clustering. Higher is better. We can also draw a silhouette plot, one bar per point, grouped by cluster. Long, even bars mean healthy clusters. Short or negative bars flag points that don't really belong. The dashed line marks the overall average. Here the plot earns its keep. On the left, a good clustering. Long bars, a high average, nothing dipping below 0. On the right, a poor one. Stubby bars and several sliding into negative territory. Same data, but the numbers tell us instantly which grouping to trust. One special case. Occasionally you do have true labels, perhaps for a test set, and want to check if your clusters recovered them. For that, use a score like the adjusted RAND index. It compares your clusters to the truth. 1 means a perfect match, and around 0 means no better than random. In scikit-learn, silhouette score gives the single overall number, while silhouette samples returns the score for every point, which is exactly what the plot draws. And when you have true labels, adjusted RAND score compares your clustering against them. To recap, judge a clustering by cohesion, tight inside, and separation, far apart. The silhouette score captures both in one number from -1 to 1, and the silhouette plot shows it point by point. If you happen to have true labels, the adjusted RAND index compares against them. Next, a different way to cluster entirely, hierarchical clustering.